guys, welcome back again. So now we're wrapping up with trigonometry part 3. Click here. Now we're doing trigonometry 3. Focus of the lesson will be the general solutions. So now trigonometry identities are true for all the replacement values for the variable for which both sides of the equation are defined. So the general solution is a formula that names all possible solutions. The procedure usually involves the use of identities, algebraic manipulation, and trial and errors. The following guideline can help lead to a solution. Find the general solution and use it to solve an angle for all values within the specific given domain. Determine the reference angle. This is important. Put the positive number for the angle in the calculator. Press the trig key and the inverse key, shift sine or shift cos or shift tan. Now, the general solution for sine. So now here you are given the sine graph. Okay, please note that now from 0 to 90 degrees here, you have got your amplitude, right? So, and then now from 0 to 90 here degrees, you've got that's your first quadrant, and then now 90 to 180, that's your second quadrant, 180 to 270, that's your third quadrant, and then 270 to 360, that's your fourth quadrant. So now about we know that now for starting from here at 60 and then up to 360. So that's why now we're saying the period of a sine graph, now we're saying that is 360. Okay, because this is a full complete wave cycle. So now by general solution, we mean that here, for example, suppose you've got your y at here, you've got y at 0.5. So here you will note that when y is 0.5, you've got y 0.5, y 0.5, you've got different x values here. For example, you've got this this value here, you've got 130 here, and then you have got another value here for 30 degrees, and then you have got another value here, and then you have got another value here for 210. So you have got another value here also for negative 330. So for different, we've got different, x values for a unique y value. So now that's why we want to try to find the general solution, generalizing all those different x values. And now we look here the general solution for sine. So if sine theta is equals to x, so now for you to get the general solution for theta, so you say it will be theta is equals to arc sine x. So you just press shift sine, or arc sine, we say it's arc sine x. Some they say it's inverse, okay? Arc sine x plus k multiplied by 360. So note that here we're multiplying by 360 because the period for a sine graph is 360. Now, whereby k is an element of real number, or theta is equals to, so this will be your reference angle, in other words. So theta will be equal to, or 180 minus reference angle, or arc sine x, plus k multiplied by 360. So we're saying 180 minus because sign is positive there in the second quadrant. Now, or for sin x is equals to, so this number here, you say this reference angle, and then you plus k multiplied by 360, and then, or you say x is equals to 180 minus reference angle plus k multiplied by 360, where k is an element of an integer, not is an element of integer, not a real number, but it's k is so here you can substitute any letter as long as you write k is an element of an integer. So now the general solution for cos. So this is the cos graph, right? So you will note that here from 0 to 90, that's our first quadrant, and 90 to 180, that was second quadrant, and 270, your third quadrant, and 360, your fourth quadrant. But now here what is important is that when your y is 0.5 here, you have got different values here. For example, you have got 300 here, and then also here you have got 60, and then here you have got negative 60, and then here you have got negative 300. So we're trying to find the general formula which will cater all those x values for a unique y values. So that's what we mean by general solution. So we're generalizing all those x values in a formula. So now for general solution for cos, if cos theta is equals to x, so your theta will be equal to arc cos of x plus k multiplied by 360, where k is an element of integer, and now or theta is equals to 360 minus arc cos, or your reference angle, plus k multiplied by 360. So note that here we're saying that 360 minus y because cos is positive in the first quadrant. And now in terms of a reflex angle, so x is equal to this your reflex angle plus k multiplied by 360, or some they also say minus or plus. So here if you can just say minus or plus, it's also correct. So your reflex angle, so you just get the negative of it. It's also, because if you say 360 minus, it's also true. So k is an element of, whereby k is an element of integer. So this should be simple. So the general solution for a tangent. So now, note that now for the period of a tan is different, because now if you look at here from 0, for example, if you look at here at 90 degree, if you look here at 90 degree up to 270 degrees, so this is your graph. So if you say 270 degree minus 90 degree, that should give you 180. So now your period of the graph is 180 degrees. And now look here, when your y is 0.9, you have got a different values here. You've got, for example, here you've got somewhere between 210, and then you've got somewhere between 45, and then you've got somewhere here and somewhere here. So you've got different values for x. So we're trying to find the general solution which will generalize all those x values. So now for a tan, if tan theta is equal to x, for your theta will be equal to arc tan x plus k multiplied by 180 degrees, whereby k is an element of integer. And then for tan x, your x is equal to reference angle plus k multiplied by 180. So your k is an element of integer. So now let's look at the equations with sine and cos. Tan 1 is type 1, our type 1, so you divide by cos. Here is the option whereby the angles are the same, the coefficient. You know, coefficient is that number. So if you have got, for example, 2x, it means 2 is your coefficient. So here they're saying that the angles are the same, but the coefficient are different. So they're saying that divide by cos, rewrite the equation with the tangent and solve it. So this type 1, right? Type 1 demonstration. We're saying that the angles are the same, we've got x, but the coefficient are different. So they're saying that you have to divide both sides by cos. So in other words, you divide both sides by cos, and then here the cos and cos will cancel. You are left with -2 here, and then sin x over cos x. We know that is a tangent identity which is equal to tan x. Then you get the arc sine x is equal to arc sine of this number -2, and so on. That's how you solve those type of questions. And now look at this demonstration number 2. Now we're saying that the angles are the same, but the coefficient are different. So now you were saying that you divide both sides by cos. So you divide by cos x minus 30, both sides. Cos x minus 30, cos x minus 30, so that this and this will cancel, and then you are left with -3. So here you have got 2, which will be sine over cos. It will be tan of x minus 30. Minus 3, which is equal to 0. And then now you transfer this to the other side, you will have 3. So you divide by 2 then you have got 3 over 2. So now you get the arc sine of 3 over 2. So you've got x minus 30, which is equal to arc tan 3 over 2, so the inverse, as you say. This should be simple. So now on demonstration number 3, you've got cos 3x plus 3 sin 3x is equal to 0. So you do the same, you divide by cos 3x, divide by cos 2x for you to get a single trig ratio of tan. So now here, when you divide both sides, you have 1, and then here you've got 3 tan 3x is equal to 0. Then you say 3x is equal to arc tan of -1 over 3. This should be simple and straightforward. Now, let's look at type 2. So this type 2, now the coefficients are the same, but the angles are different. The angles are different. So now you convert sine to cosine, cosine to cos, because they are cofunctions. And now sine theta, for example, is equals to cos 90 minus theta, because the cofunction of cos theta is equal to sin 90 minus theta, because the cofunction is 90. I said this is a cofunction. So now you equate the angles and solve it. You equate the angles and solve it. Now let's look at the example. In the example, you've got maybe sin x is equals to 3x. So here the coefficients are the same, but the angles are different. So now you have to choose whether you change sine to cosine or cosine to sine. So now if we start by changing this sine x to cosine, it will be cos of 90 minus x. It's true, which is equals to cos of 3x. All right. So now we're saying that we equate the angles. The angles is 90 minus x and 3x. So you just equate the angles, because here you've got the same cos and cos. So now, which will be 90 minus x is equal to 3x plus k multiplied by 360. And then you solve. Or 90 minus, because it's cos, you've got negative and positive. So it will be 90 minus x is equal to -3x plus k multiplied by 360, where k is an element of integer, and then you solve the equation. You solve for x and so on. This is simple. Or if you choose to convert cosine to sine, you will have sine x, which is equals to sine 90 minus 3x. So now you just equate the angles. X is equals to 90 minus 3x, and then x is equals to 90 minus 3x plus k multiplied by 360. Or because it's sine, I said x is equal to 180 minus, because sine is positive with the 180, 90 minus 3x plus k multiplied by 260, where k is an element of an integer, and so on. You solve. You just choose here which method is good for you. Now let's look at the term 5. So suppose here the coefficients are the same. So now if the coefficients are the same, I said we equate the angles. So now here, but you just have to transfer this to the right hand side. So you left sine 2x is equal to cos of x minus 30, right? Whichever which way you can just choose to change this or this, it's up to you. So here we're changing cos, we're changing this sign to cos, it will be 90 minus 2x is equal to cos of x minus 30. So now we equate the angles, so it will be 90 minus 2x is equal to x minus 30. And then now you've got 90 minus x is equal to 3x plus k multiplied by 360, 90 minus x minus now minus 3x plus k multiplied by 360, where k is an element of integer. So here you just choose whatever, which way. So sine 2x is equal to 90. So now you're changing this part now. It will be 90 minus x minus 30. So sine 2x is equal to sine of 120, okay, minus x. So 2x, now we equate the angles. It will be 2x is equal to 120 minus x. So 2x is equal to 120 minus x plus k multiplied by 360. And then 2x is equal to 180 degrees because it's sine, minus 120 minus x plus k multiplied by 360, where k is an element of integer. So now, given that, we can look at type 3. So the thing that the coefficient and the angles are different, when the coefficient and the angles are totally different. So now you apply the basic identities if needed, or you apply the double or compound angles formula. So you factorize by taking out the common factor, trinomial, etc. And then you solve the equation. So now here on demonstration number 6, determine the general solution of the equation cos x minus 60 is equal to 3 cos x, right? So here you have the angles are different and the coefficients are different. This is simple. You just have to expand this side on the left using compound identities that we have been doing. So now when you expand, you have cos x minus 360 is equal to 3 cos x. So it will be cos x multiplied by cos 60 plus an x multiplied by sin 60, right? So now by expanding this, you know that this has your special angle. So you'll have 1 over 2 for cos 60 multiplied by cos x plus sin 60. You know that that's a special angle. After rationalizing, it will be root 2 over 2 sin x, which is equals to 3 cos x. So now you divide both sides by cos x, and now you will have got, here you will have a tan, root of 3 over 2 over tan. That's a tangent. So identity, quotient identity. So now here you're left with 1 over 2. The cos and the cos will cancel. So now you come here, you just multiply throughout by 2, so that you'll have 1 plus root of 3 tan x is equals to 6. Just multiply throughout. So now you transfer this on the other side, it will be 6 minus 1, which is 5. And then you divide by root of 3, which will give you 5 over root of 3. Then x is equals to arctan of 5 over root of 3, which is x is equals to 70. And then x is equals to 70.9 plus k multiplied by 180 degrees, because that's a general formula for tan, whereby k is an element of an integer. So now let's look at the type 4. So the thing that quadratics and factorization, if there is a more than one trig function in the equation, identities are needed to reduce the equation to a single function for solving. Factorize the equation, some will need quadratic formula. So now let's look at this demo. So suppose you are given cos 2x minus an x minus 1 is equal to 0. So now note that this is a double angle identity. So you have to choose. Which one do you choose? You have to choose 1 minus 2 sine squared x, because here you've got sine x, so that it will be simple for you. Here you will change this is to 1 minus 2 sine squared x minus an x minus 1, so that it will be simple for you to work out, because already you've got sine here, this side. So which will give you minus 2 sine squared x here minus an x. So 1 and 1 will be 0. So now here you can take out the common factor of negative sine x, which is equal to 2 sine x plus 1 is equal to 0. So now this sine x is equal to 0, or here you will just say 2 sine x plus 1 is equal to 0. Then you transfer the negative 1. This side will be negative 1, and then you divide by 2, which should be simple. And now at the demonstration number 8, you've got 3 sine squared x plus 2 cos x plus 2. So here now because you have got cos next to cos squared use. So in other words, you just have to change this. So you can just say sine squared x equals to 1 minus cos squared x from square identity. So you have got 3 sine squared x plus, so you just come and say it will be 3 into 1 minus cos squared x, which will give you 3 minus 3 cos squared x plus 2 cos x plus 2 is equal to 0. So if you are here, you can have negative 3 cos squared x plus 2 cos squared x. So 3 plus 2 is equal to 5. And then you can choose to multiply throughout by negative. You can have 3 cos squared x minus 2 cos x minus 5 for you to factorize this trinomial. So you can have 3 cos x and cos x, and then you can have minus 5, and here is cos x. You can have 1, and then you solve. Okay, for example, another example, suppose you are given cos 2x plus sin 2x plus 2. So all these, they are compound angles. All right, so because you've got cos and cos, so you can choose here. Here you've got 2 sin x cos x. Okay, so here you can choose this one, sin squared x minus cos squared x. Right, here is minus. Okay, now you've got cos squared x minus sin squared x plus sin x multiplied by cos x plus 2 sin squared x. So you also change here, 2 will be 2 multiplied by 1, which will be 2 sin squared x plus 2 cos squared x, right? You just change 2 multiplied by 1, which will be this, is equal to 0. Then you solve, it will give you, you simplify this, it will give you 3 cos squared x plus 4 sin x multiplied by cos x plus sin squared x, and then you factorize here, you go 3x and cos x, and then you go sin x and sin x. It's all positive because here they are positive. Okay, now let's look at example number 1. So they say that determine the general solution of cos 2x is equal to sin 89 cos 29 minus cos 89 sin 29. So this should be simple. So you start by this side. Here, because it's sine, it will be sine of 89 minus 29 this side, which will give you sin 60, and then cos of 2x is equal to root of 3 over 2. you can just come here, and then you get 2x is equals to arc cos of root of 3 over 2, which will give you 30. And then you've got 2x here, 2x equals to 30 plus n multiplied by 360, or k multiplied by 360, is up to you. Where n is an element of, you also write where n is an element of integer. So when you divide both sides by 2, you've got x is equals to 15 plus n multiplied by 180. All right, because it's cos, you can also have a negative here. Negative of this, 2x is equals to negative 30 plus n over 360. Then this should be simple. So on example number 2, say find the general solution of cos of x minus 15 sine of 2x minus 15. So here we've said that you can change into co-functions. All right, here the coefficients are the same, but the angles are different. So it should be simple. It will be cos of x minus 15 is equals to cos of 90 minus 2x plus 45. So here you equate the angles, right? You just equate the angles. So you will have x minus 15 is equals to 45 degree minus 2x. So this your reflex angle. So now x minus 15 is equals to 45 minus 2x plus n multiplied by 360, where n is an element of integer. So now when you transfer this, it will be x is equals to 20. We solve for x here. Be x equals to 20 plus n is equals to 120. And then now x minus 15 is equals to negative. Here is 260. So it will be x minus 15 is equals to negative 45 minus 2x plus n multiplied by 360, where n is an element of integer. And then you solve for x here, you solve for x, then it will be x this side, and then 45 and 15, negative 45, and we'll add to 15 and plus n multiplied by 360. So your x will be equal to 30 plus n multiplied by 360. So this is simple. You just use your calculator here. Okay, let's look at example number 3. Then determine the general solution of the following equation. So now you've got 1 plus sine 2x is equals to 4 sine squared x. So here you can also change this one to a square identity. You can also change this to a double angle identity. So this one will still be sine squared x plus cos squared x, and then you've got 2 sine x cos x this side. So this one you will transfer it to the left hand side. You've got negative 4 and squared x equals to 0, and you solve. It should be simple. Here you've got sine, and then here you've got sine, which will give you negative 3 sine squared x, and then cos squared x, and then 2 sine x cos x. So here you factorize cos x and cos x and x and sin x. Here there's 3. So you will have cos x plus 3 sin x, which is equals to 0. So you transfer the cos to the other side, or the sine, it's up to you. Then you end up having cos x is equals to negative 3 sin x. And then when you divide both sides by cos, you'll have 1 this side, and then negative 1 over 3, and then tan x. So now all your x will be equal to, so when you say arc tan of negative 1 over 3 will give you negative 18.43 plus n multiplied by 180, because that's tan. Okay, n is an element of an integer, and x will be equal to negative 18.43. N is an element of integer. So now all you come in here, you say cos of x is equals to sin x. You solve the other bracket here. which will give you, you divide both sides by cos here, it will give you tan x is equal to 1. So your x is equal to arc tan of 1, it will give you 45 plus n multiplied by 180. N is an element of an integer. So this is simple. So your home task, the same determine the general solution of 2 sin 3x is equal to negative cos 3x, and then determine the general solution of sin 11 cos 55 plus cos 55 sin 11. This is also simple. We did example like this. So if you've got any question, you can put on the comments. And then you've got also number 3, solve for x, and this is sin x minus 60 is equal to minus cos 2x, and then solve for x again, or find the general solution. You've got tan of 2x equal to negative tan x. And then if you've got any question, and put on the comments, we will help you. And then thank you. Don't forget to like, comment, subscribe the channel.